So continuing on, what we're gonna do here is we wanna, this is the overall data flow. We're gonna import the data. Data is gonna be imported to centralized database via SSIS package. Then we're gonna clean it, validate it, and then menu items will be indexed. The SSIS package looks like something like that, where we're gonna connect to all the clients. We're gonna loop through each one of them. We're gonna import the cuisine types. We're gonna import the delivery locations. We're gonna import catalog. We're gonna import all the restaurants, and we're gonna import all the order history actually. Now what's important to us is this menu catalog, which is basically menu items, menu descriptions, because those will turn into our feature set vectors that we're going to use for clustering. Continuing on, once the data is imported, we're going to process the data. Basically, we're going to look at menu items in a particular zip code. We're going to determine the feature set vector, which is going to be based on restaurant ID, description ID. It's going to be based on menu items, cuisines. Then we're going to stem it using a snowball stemmer, and then we're going to build a 2D hash table with how many times the terms are occurring. Then we're going to perform our clustering, k-mean clustering, to determine which items to suggest to the user, and then we're going to use cosine similarity to find most similar items. The feature set is based on the following database schema. As you can see, that we have menu, which is one-to-many to restaurants, and also a menu can have many headings, and then each menu headings contains menu items. For data processing, we're going to use the following features, as I mentioned: restaurant ID, menu ID, restaurant name, menu item description, cuisine, and then we're going to use stemming to retrieve common stems, so we can actually index and build our hash table, which is going to be based, it's going to look like that. So basically each item tells you how many occurrences of this is menu ID from the database, and then how many times this term occurred in the description of this menu item. And if it only occurs once, there's going to be a 1. That's the convention that we're using. So that's the data file. Once we have the data file, we're going to run k-means clustering on it to compute, again, following our methodology. We assume that similar items are in similar clusters, and then the similar items are going to be different clusters. And then we're going to rotate, we're going to implement two public methods: search to get items in the same cluster, or rotate to get items in a different cluster. Gonna seed the cluster with square root of number of menu items. So once the clustering is completed, which takes a long time, about 4 hours, after that it's going to be brought online, and then the user can query for suggestions for similar items or dissimilar items. We ran this on 2 zip codes, which are the most, has a decent number of restaurants. It took over 4 hours, as I said, had about 90 clusters. A lot of them, some of them were very sparsely populated because of their specific restaurants with very unique cuisine times, and it's better k-means clustering. We determined that it's better just random picking. In the future, we're going to expose this functionality via REST SDK, so our other API can use it, and then we're going to incorporate Yelp reviews to do a better job at clustering. So here's the database, as I mentioned, with all the data imported. What I did was we ran the clustering algorithm, and here's the example that it has been running for over 4 hours, and I put a breakpoint once the k-means, this is a driver program, once the k-means has been completed using 2 iterations. And so I show you, we can step through. So this is my cluster class. It's been loaded, initialized, been loaded, k-means has been computed. Now we're going to simulate a client showing which items they already seen. So these are menu IDs, menu item IDs, basically from the database. So you We push back on those. So now this one has 5 elements. And now we are saying, okay, I will feel like chicken club sandwich. So you're going to search for chicken club sandwich. This is going to perform the search on the cluster, and it resulted in suggestions. These are the menu items which are the most similar to the chicken club sandwich. And so now what needs to happen, as you can see, we need to look up in the database what the items are, and then we can provide the feedback. And then it prints them out. And then here's an example of rotation. So that's going to give me, using these scene vectors, it's going to rotate the cluster and give me the most different items. And results, these are the next suggestion results, and it's going to print them out. And those are going to be the next item ID suggested, and that this will be hosted by as I mentioned, is this going to be hosted by the API that's going to expose this functionality via the clustering server via SDK. Thank you very much.